this is the idea. This was explained by Richard, but essentially, I've walked all over this area, so you don't have to. But I would absolutely recommend it. We are living in some of the most extraordinary countryside, and you shouldn't underestimate its beauty or its meaning in terms, or geologically, its meaning in terms of how it got there. So I'll start with this. This is obviously Box Hill. This is the view from Box Hill. Starting with the scarp over here. This is Dorking. You are about here. No, actually, that's the church. You're there. This is the green sand ridge, Leith Hill, that Richard was talking about. The mole goes down along here. The Gulp clay is down here. And this is the Weald, this broad open plain here. Somewhere out there, there are some more hills, which are the Jurassic, but essentially they're a long way away. And there's a lot of Wealden clay and other material being eroded away from here. So fantastic view from Box Hill across the lower Cretaceous. Now, just to put things in place, this is the OpenStreetMap. So Dorking down here, Leatherhead, and other important places. That's where I live. Box Hill is there, and you were looking south from there, off in this direction, well, or right the way around that arc there. But that's just a map. It's just flat. Let's put some topography on it. So I'm going to be using quite a lot of this LIDAR data. Now, this is topographic data that's freely available online. It comes from the Environment Agency and is down to 50 centimeters resolution, both vertically and horizontally. And it covers the whole of the country. It was flown from airplanes a while ago, and it's just there to be used. And LIDAR stands for light detection and ranging, and whatever that means. So some lovely, you know, you get the fancy software and then you can drape something on it and it makes it all look nice. Just in case you were wondering, that's where you are at the moment. This quite clearly is the Mole River going through here, Leatherhead up here, etc. This is, LIDAR comes in two flavors. There's this one, which is the surface model, which is basically what's there. So you can see, you know, all the trees and the buildings and the whole of Dorking and railways and everything there. And it also comes in a terrain model where, using fancy things in their computers, they can remove all of that stuff. So it sees through the organic matter anyway, but they've removed all of the buildings and everything else. Obviously, some things you can't remove. The M25 is one, railways. But essentially, this is the surface. This is the surface of the Earth, and it is very old. We're going to start with looking at a little a picture from Box Hill here across in this direction. And this is Ranmore Scarp. So Ranmore is up here. This is Denbies. Richard mentioned that. You'll be seeing more pictures of vines. But the important thing here is that here is a steep scarp running down, and then the gentle dip slope of the chalk as it goes off to the north. The this valley here, this is not the front of the ridge of the North Downs. That's there. This is a dry valley at the side, just behind there. And this is that valley, covered in all sorts of wonderful grapes. And that little spire there is Ranmore Church, if you're aware of it. If you look the other direction, then basically that's what you see. So again, the thing I just described, which is that steep slope, grading off to very little down the bottom here, and then that gradual slow dip of the chalk to the north. This is the LIDAR data just colored up. That's all I've done in terms of heights. And the range of heights is quite well, it's quite a range of heights, let's put it that way. So the highest point around here is along to the west. No, yes, to the west. And then not Box Hill. Box Hill is not one of the highest points, but a bit further along. Weirdly, neither of these points have names. You'd have thought somebody would have called them something, but I can't find a name for them. At the foot of the escarpment down here, the Mole Valley is at 40 meters. So the difference is something like 180 meters between the top of the hills and where the Mole Valley goes through before it goes through the valley. Richard mentioned the Pit Brook, which runs along here. It drains this front of the chalk scarp within the Galt clay down here, and the mole turns left as you come out this way, and then runs along the Galt in this direction before it cuts through these sands. But the mole drops about 10 meters through the Mole Valley. Up here, it's at 30 meters and 40 meters here. So there's about a 10-meter difference as you go through. Now we're going to look across at Dorking from the top of the hill there. And just, I keep doing this, but there you go. There's it. That's the church in Dorking. That's the Greensand Ridge behind Dorking. And this is all chalk. Just the scarp is just the other side of these trees at this point. This is the geology. So again, Richard has described this, so I won't spend a lot of time on this, but here is the Wealden, Lower Cretaceous. This is the lower greensand, these green colors here, that one, and some others down there. That's the Galt clay running through there. That there is the upper greensand, and then you've got the chalk from here right the way through to here, and there's lower chalk, middle chalk, and upper chalk. Up here, you come to the tertiary with an unconformity sitting on top of the chalk. This is the Thanet sands, and then the Reading beds, and finally the London clay, which just goes on and on and on. So there you have it. Going to look off in that direction now from over there. And again, just to re-emphasize, the base down here is Galt, then you've got the upper greensand in here, which is mostly worn away, but the scarp is in the chalk right the way up. In terms of ages, Lower Cretaceous is about 113 to 134 million years. The Upper Cretaceous, the chalk, is in this instance, from that unconformity, is about 72 to 113 million years worth of deposition. And then the Eocene is all of this lot. The Paleocene is about round about 59 million years, and the Eocene is less. It's worth dwelling on that. These are very long periods of time. Geological processes are very slow, but they are inexorable. The other thing it's worth thinking about, or worth remembering, is that the chalk is split. Just go back into that one, into the lower, the middle, and the upper chalk. The big difference is, as far as we're concerned, of those, is that the lower chalk has clay in it, and the upper chalk has most of the flints in it, and the middle chalk is a bit of chalk in between. Now, that means that the old lime works and the cement works. So this is Dorking. This funny thing here is Betchworth, and there are some others along here. They were all focused on the lower chalk, because you need clay to make cement. You need clay in your chalk. And like I say, most of the flint you'll find in the upper chalk. That's important, and we'll come back to it. So we looked at that. Right, so let's look at some of these extraordinary features, because obviously there's, the Mole Valley, but there's these things off the side which are just beautiful and very distinctive. So just to describe them, what you have is a meandering valley here. There's another one over there. There's another one here. There's another one further along, with a steep south-facing slope. That's this side of the valley, and a gradual slope on the other side with these deeply incised valleys all the way up there. Very distinctive. The two sides of the valley, very, very different. So what we're going to do is we're going to look over here, first of all, at the slope of the chalk itself. I'm going to look up the slope and then down the slope. Oop, come on, there we go. So this is on Effingham Golf Course, looking up the slope, and you've got this sort of gently undulating slope along here, and you're actually on the chalk here, and so these wonderful wildflower meadows, chalk meadows. And if you look the other way, you can see right the way across the London Basin. This is the London Basin out here. So essentially, most of what you can see there is London clay. And if you don't believe me, this is the same view from Norbury Park, and that little bit there, you can see London. You don't believe me, do you? No. So there you go. So there's the Shard, and here are a bunch of other of the London buildings. So you can see London from the North Downs. So that picture was taken from here, Norbury Park, Norbury Park, looking off in that direction. Now we're going to look along the Polesden Lacey Valley, which is this one here. So I'm going to show you some pictures down, view down here, and then a view up at its end, because it comes up here and then turns up and then sort of peters out. So this is the Polesden Lacey Valley. Again, this is the south-facing slope, so it's relatively steep, but sort of nicely undulating and smooth. This is the base of the valley running beautifully meandering down through here. And this is its where it begins to peter out as you go up the hill after it's turned the corner. So Polesden Lacey itself, so I've switched to the surface model here, so you can see the buildings. Polesden Lacey is there, and then West Humble is here. if you know West Humble. There's a valley coming up there. This is Polesden Lacey. That's the National Trust House in Polesden Lacey. And this is its valley. So it was sited beautifully to overlook the dry valley. And this is the view from the other side of the Mole Valley. This is West Humble, and this is the mouth of that Polesden Lacey dry valley. And you can see it meandering off, and eventually it goes off around that corner there. So it's a beautiful valley. And on the southern side of the valley, you get these steep-sided little valleys. You don't see anything like this on the south side. Steep-sided valley running down into it. There's another one. This is Hogden Lane, and that is genuinely the side of the valley. So there's a series of these. This is the Polesden Lacey Valley. Hogden Lane I just showed you. I showed you one of these as well. But there's these Honeysuckle Bottom, if you know it. Green Dean runs right the way through, and various other ones around. Now, if you've ever driven along the A246 up here from Leatherhead to Guildford, which is about where that mark is on the brick, you may have wondered why the road goes up and down and up and down and up and down, because it does. And that is simply because what you're doing is you're driving over the next set of these valleys that are running off of this ridge halfway down the chalk. So these valleys here. And if you drive along here, next time you do that, if you do it, you need to remember that every time you do this, which will be very common, that's another glacial valley, periglacial valley. And so this is an example. This is a wonderful old picture from Effingham. This is the old toll gate at Effingham, a chalk surfaced road. If you took somebody from the 1800s, which is when this was taken at the end of the 1800s, and plunked them down into Effingham or anywhere around here today, the first thing that they would notice and think, oh, that's odd, is the colour of the roads, because they were all chalk surfaced in those days. So white roads, a gentleman of the road, and some vehicles. But this is another one of these dips. So that was actually taken there, looking at that dip there. Now, on the other side of the Mole Valley, over here, we have, this is Headley up here, this is the Headley Valley, which is pretty much doing exactly the same thing on the other side. The valleys over here aren't really called anything, with one exception. This is Headley Heath up here, and then down here is the Zigzag Valley and the Zigzag Road. If you've ever been up to Box Hill, you've gone up the Zigzag Road, it's that valley there. So this is the Headley Dry Valley. Again, much the same as Polesden Lacey on the other side. There's the south-facing northern side of the valley. So steep, smooth, and gently undulating. And here are some of the steep valleys running down towards the north on Headley Heath. And it's quite obvious that it's very different from the other side of the valley. But rather beautiful. And that's the next valley going up there. This you may recognize. There's a road there. This is the Zigzag Road. It's come up there, goes around there, and goes up here. So this is the Zigzag Valley. And as you can see, and if you've ever been up there, you will know this is a very steep-sided valley, as they all are. and is a very good example of one of these steep valleys, incised valleys running down towards the north. So that gives you an idea of a description of what's going on here. But how do they form? Now, if like me, you actually live on the chalk, your terrain is classified as thin soil over chalk, which is exactly what you're seeing here. This is the soil, this is the chalk. There's precious little for things to grow in, but they do, rather miraculously. But even after last night's thunder and lightning and torrential rain and everything else, water's gone. It goes. It sinks into this stuff like nobody's business. There is no erosion on the chalk. So that's a bit weird. No runoff, no erosion. So really, if you're going to erode out those valleys, it can't have happened during, recent times, because the water that goes in there disappears. And in fact, if you're going to erode that stuff, it can only have been done when the ground was hard. And that, of course, was when it was frozen. So a little bit about the Ice Age. Over the last 50 million years, we have been getting gradually colder and colder and colder. So from about 50 million years ago, in the beginning of the Eocene, average global temperatures were considerably warmer than they are now. So this is the time of the London clay. So in that period of time, things have got a lot colder. And in the last couple of million years, and I'll close in on this, it's got a great deal colder again. And it could be because around here, the Isthmus of Panama, basically South America and North America joined. And so you couldn't get oceanic circulation going around there. So oceanic circulation patterns changed completely, and you start in this area, you start getting these much colder temperatures. Let's just zoom in on that and just note that humans have only been around for this little bit of time here. I'm going to say hominims are only going to be around for this little time here. And we might worry about what we're doing to the climate, but we're doing nothing compared to this. Mind you, that's over 50 million years. So this is the last 5 million years, Pleistocene over the last 2.5 million years. And you can see what happens is that there's a steady downward trend, but it also starts to get very much more variable. And these points here, all of these little points, the minima along here are the ice ages. And then between them, it gets quite warm again, but only relatively warm, not as warm as it used to be. So it goes up and down and up and down. The maximum, okay, was at this point here. And then the most recent was here, and we'll look at those sorts of things. One of the things that happens during an ice age, when you create a lot of ice, hence the name, and then you pile it on land, is that sea level goes down, because basically you're locking up that water and sticking it on land in terms of thick ice. And so sea level has gone down, or at those times was very much lower than it is now. So this is the maximum. This is the one that Richard was talking about, where it is believed that the ice came down to just north of London. In fact, the Thames used to run out through Suffolk up here, and it was diverted during this time, and only now runs through to what we call the Thames estuary. This is the point at which, in theory, if there were hominins around, you could have stood on the hills here and maybe just have seen the glaciers in the distance. Maybe. But the other thing is that this is basically the edge of the land. The sea retreated way, way out here to what is currently the shelf edge. So there's sort of quite shallow seas, and then it drops off to the very deep sea, and that's here. And the Thames, there's bodies of water here, but the Thames, the Somme, the Seine, basically all of the North European rivers and all of the South British rivers basically emptied down into the Channel River, which went all the way down here and across to the shelf edge here. All of this was land. There was no distinction. That's the maximum. The most recent was the Devensian Ice Age. And this only ended about 10,000 years ago. Now, you might think that's a long time ago, but geologically speaking, that's yesterday. It is very soon. And during the Devensian, there was an ice cap basically on Scotland and much of Ireland and Wales and all of this sort of area. And again, same sort of thing before. The edge of land was way, way out here. And again, all those rivers, the now diverted Thames, joined up with the Rhine and the rest of it and poured down the Channel River. Now, our local area was down here, within what's called here an area of extensive permafrost. What does that mean? That means the ground is frozen. It is bloody cold. And the ground is frozen to some depth. Essentially, it's tundra. Whether or not you've got mammoths wandering around at the peak of this is another matter. But certainly, as it built up or as it went away, and if things got a bit warmer than they were there, and there would have been at the peak time very little vegetation for a mammoth or indeed anything else to eat. So what this does is, on the chalk, the freeze-thaw action, or just the freezing, chalk, as Richard explained, because of the Mole Valley, is very absorbent, takes a lot of water into it. And if you're in a very, very cold environment, then obviously that turns to ice. And ice occupies more space than water. It expands. That's why ice floats. It's less dense than the water. So it will break up whatever it's in. And that's what you can see here. Now, this is recent. This is freeze-thaw action recently. And you can see this is the top of the chalk, but it's just a mush of bits and pieces of chalk, and it's marl, really. Well, it's not even marl, it's just chalk mud. So what would happen during these periglacial times? So you get the water freezing the layers of the chalk, it breaks it up, and then if you've got a sunny south-facing slope, now, you know, it may be the Ice Age, it may be very cold, doesn't mean you don't get clear days. So the south-facing slope, looking directly at the sunshine, warms up, and the ice melts, and all of this broken up material sloughs off, and gets washed away downhill during the next melt, rain, snow, whatever. So you develop on those south-facing slopes, the scarp. The reason the scarp is that shape is because you've developed these you've developed them by sloughing off material continually over long periods of time. On the other hand, if you're on the north-facing slope of one of those little dry valleys, then that never happens. It's just cold. But of course, it will still rain. You'll get melt. You'll get stuff coming off the top of the hills that will run down in these valleys, and basically you'll get erosion. So you get deep erosion on the north-facing slopes, and on the south-facing slopes, you get this even sloughing away of the surface. There are other things going on which we don't see very often. So these are two examples that I've seen from elsewhere. I haven't actually seen this around here, though I believe it does exist. This is a thing called cryotubation, where essentially you've got water in the surface layers melting and then freezing and melting and dissolving some of the chalk underneath. This is chalk, this is chalk, and you get blobs of overlying material just sinking down into this melted surface layer when it melts. And at Broadstairs in Kent, where we went earlier this year on a field trip, there's this extraordinary set of blobs, blebs, sort of sinking down into the top of the chalk cliff. Just remarkable.